Hey folks, so this is a video for section 4.1. Gonna keep it moving quickly. You probably will have to pause and rewind a good bit throughout the course of this video, so be prepared for that. All right, so here we go. Chapter 4 is all about antiderivatives. Think back with me. Chapters 1, 2, and 3, we have done nothing but work with derivatives. And so chapter 4 is an antiderivative chapter, and literally what we're doing here is we're working backwards. So take a look at the first question here. If I gave you a first derivative that was equal to 3x squared, what would you have to do to go backwards to find your original f of x? Well, let's see. Your power would do what? Well, let's see. Your power goes down 1. So if I'm going backwards, my power needs to go up 1. And that power goes out to the front. Oh, so how do I deal with that? So if you're thinking, well, you know that you're going to have an x cubed as your original. But think about this. Couldn't all of you choose a different constant to add? Like somebody could say that I want to find the derivative of x cubed plus 5. And wouldn't that derivative still be 3x squared? Somebody else might say, well, I don't want the derivative of x cubed plus 5. I want the derivative of x cubed plus 35. And again, you're going to get that exact same derivative. So we have to understand that adding a constant, we need to always allow for that adding of a constant that we don't know what that constant is. So we'll just say that it's going to be plus c plus a constant. All right, so what we have here, this symbol that you see right here, this is the integral symbol. And by the way, antiderivative is the same thing as an integral. So you may hear me go back and forth there. The integral of a derivative sends me back to the original. But again, don't forget, it's going to be my original plus some constant. Now, for right now, I have one rule. And by the way, you're going to want your formula sheets during this particular section. So make sure you have your formula sheets out. Specifically, I want you to have the formula sheet out that has the list of derivatives and integrals on it. And we're going to be looking at the second half of that formula sheet, the integrals part of it. We really only have one rule, and that's going to be the power rule. And so what we're going to do is if I want the integral of x to the nth dx. And by the way, before I move on with this, the integral symbol and the dx, they are partners in crime. You cannot leave off one without having the other. They have to go together. And so my symbol is not just the integral symbol, and it's not just the dx. I have to have both of those. They must go together. And so anyway, back to the power rule. When I have the integral of x to the nth dx, my power is going to be raised by 1. And that's what you see right here. My power is going to be raised by 1. And I'm going to be multiplying by the reciprocal of that new power. The reciprocal of that new power. And of course you see there that I'm adding a constant. Some tips here before you integrate, make sure you always have a polynomial. So in other words, make sure that your variables are in the numerator and that all of your terms are either added or subtracted. We don't have any product rule. We don't have a chain rule. We don't have a quotient rule. So the only thing I can do right now is add or subtract. So let's go ahead and look at the indefinite integral here for number 16. And by the way, everything in section 4.1 is going to be an indefinite integral. We'll deal later with what a definite integral is. And so the first thing that I would like to do, notice that I am subtracting two terms here. So I just want you to understand that I can totally separate these. And so I'm going to take the integral of 13 dx, and I'm going to subtract the integral of x dx, and I can treat these separately. Kind of like with derivatives. You remember how we can separate with adding and subtracting derivatives. So this is the same concept because this is just the backwards version. And so the integral of 13, think about if you have to go backwards, what function gives you a derivative of 13, and we would say that that's a 13x. Again, think backwards. If you were to take the derivative of 13x, you would just get a 13. So we're working backwards here. And then secondly, whose derivative would just give you an x? Well, think about the power rule. The power rule is really easy to do this one on. So take your power, move up by 1. So that's going to be an x squared. But then you also want to multiply by the reciprocal of that new power. So it's going to be 1/2 x squared. Try it out. Go ahead and take the derivative of this term, and you will see that you are just getting an x. Don't forget to add the c. Moving to the next example. So again, I have 3 terms here. I can look at these 3 terms separately. And so I want the integral of 8x cubed dx minus the integral of 9x squared dx plus the integral of 40x. I can take each one separately. And not only that, let me show you something else on this. Remember the constant multiplier rule that we used back in derivatives? I have the same thing. That 8, that's a constant multiplier, I can take that out in front of the integral and not even really worry about it. The 9 that's in front of the next one, I can pull it out front and I don't have to worry about it. It's just a constant multiplier. I can even do the same thing with the 4. It's not as necessary to do that, but nonetheless, I can do that. Okay, so then what I have for that first term, I have my 8. Now let's use the power rule on the x cubed piece. So the x cubed is going to move to an x to the 4th. And then you want to multiply by the reciprocal. So you see I copy the 8, and I have 1/4 x to the 4th using my power rule. For the next piece, copy your minus 9. And then your power is going to move up by 1, so your x squared is going to move to the x cubed, and you multiply by the reciprocal of the new power. That's your 1/3. Your plus 4, just go ahead and copy that, and then you just have an x. Again, think about the derivative of 4x is just 4, so we're just moving backwards on that. So if you just have a constant, just tack an x onto it to get your integral. Don't forget, you've got a plus c there. Let's go back and clean this up. Each of those 3 pieces can be cleaned up a little bit. And so you have 2x to the 4th minus 3x cubed plus 4x plus c. All right, number 20. Remember that I said make sure your variables are in the numerator and make sure that you're just working with normal variables here. So this first piece, I'm not going to think of this as a square root of x. I'll think of it as an x to the 1/2 power. The second piece, I'll think of it as a 1/2 times 1 over the square root of x, but then that 1 over square root of x piece I will think of as an x to the negative 1/2 power. So that's where we'll head here. So my first term, I can take the integral of x to the 1/2 dx. For my second term, I've got my 1/2. It's a constant multiplier, so I can just move it out to the front, times the integral of x to the negative 1/2 power dx. All right, so I'm ready to use my power rule then. Once again, take your power, move it up by 1. So if you think about 1/2 plus 1, or 1/2 plus 2/2, that's the same thing as x to the 3/2 power. But then don't forget, once you have x to the 3/2 power, you want to multiply by the reciprocal of that new power. All right, so then let's go to the next term. The 1/2 piece, just copy that piece down. But let's think about what happens with this guy. So take your power, move it up by 1. Negative 1/2 plus 2/2 is the same thing as a positive 1/2. So you can see here that the first piece I just copied, my constant multiplier. Here's where my power moved up by 1, and then I also need to multiply by the reciprocal of the new power. Don't forget that you've got a plus c here. All right, let's clean each piece up then. And that first piece doesn't really have any cleanup to do. The second piece, I can multiply my reciprocals together, and then my plus c doesn't have any cleanup either. Moving to number 22. Clean up your first piece. Remember that the way that you deal with roots, the power goes on top, the root goes on bottom. So this is the integral of x to the 3/4 dx plus the integral of 1 dx. So that first piece, let's move our power up by 1. When you take 3/4 and you add 1 to it, that's 3/4 plus 4/4, which is going to be a 7/4. But don't forget to multiply by the reciprocal of that new power out in front. And then remember, when you just have a constant, all you need to do is tack on an x. So this is a 1x, and then I have my plus c. And everything's already cleaned up, so I don't need to go any further with that. All right, on the next one, again, splitting them apart, we'll have the integral of 2 dx minus, okay, so my 3 is a constant multiplier, and let's take that x to the 10th and move it to the top. So that'll be a minus 3 times the integral of x to the negative 10th power dx. All right, taking one at a time, the integral of 2 dx, that's just a constant, so tack on an x. Your minus 3 can just stay where it is. So again, let's talk about what happens on the power rule. Take your power and move it up by 1. That's going to be x to the negative 9th. X to the negative 9th. And then you want it to multiply by the reciprocal of that new power. So multiplying the reciprocal of the new power then is going to be multiplied, oh, I'm sorry, I erased that, is going to be multiplied by that negative 1/9. Okay, so then let's clean up each of those pieces, and I'll have a 2x. 3 times 1/9 is 1/3. The two negatives make a positive, and then I still have my x to the negative 9th. Now, because I have a negative power there, I could also write this, that middle term, as a 1 over 3x to the 9th. Either one is okay. I quite frankly do not care which of those you have. Neither is more simplified than the other. All right, for number 26, on this one, what you need to do is you need to take your existing denominator and you want to share it with all 3 pieces of your numerator. Make 3 separate fractions, and then you can reduce each of those 3 separate fractions. Because remember, we don't have a quotient rule. You can only use adding and subtracting here. So the first thing that I'm going to do is make my 3 separate fractions. My first fraction will reduce to just a 1. My second fraction, that 3x squared over x to the 4th, will reduce to a negative 3 times the integral of, it would really be a 1 over x squared, but I went ahead and moved that x squared to the top, making it a x to the negative 2nd power. And then for my last term, move the x to the 4th to the top, and you just have there an x to the negative 4th power. So then what we're going to do is take the integral of each piece, and so the integral of 1 is just going to be x. Go ahead and copy your minus 3 down, and let's take a look here. The integral of x squared, move your power up by 1. That's going to be x to the negative 1st. Multiply by the reciprocal of your new power. That's just going to be a negative 1. Excuse me. And then for the last piece there, copy down your plus 5. The integral of x to the negative 4th, move it up by 1 the power, x to the negative 3rd. Multiply by the reciprocal of the new power. And now let's clean up all 3 of those pieces, actually just 2 of those pieces. And this is what you have. All right, I'm going to pause the video for a moment and get this cough out of my throat really quickly, and then I will be back to finish up.